Hello friends, on today's workbench we've got a Bassman 50. This is an amp from the kind of mid 70s, I'm guessing. I haven't dated it yet. And it's actually an amp from a subscriber of the channel who wanted me to go through it and see if it needs any work and to make it reliable and good to go for the long term. So here we are. Now at the onset, I do want to say that I have never worked on a Bassman before. I've never played one. I've never spent any time with one. I should say a Bassman head. I have played a Tweed Bassman reissue for a while. But yeah, this is all completely new to me. And then on top of that, this is obviously a 70s era, which is pretty different from the blackface era. Just components used, how they do things. So this is also just all very new to me. So I'm going to be taking it slowly and yeah, just kind of learning as I go. And as always with all of my other videos, just taking you guys along for the ride with me. So visually, the amp looks very, very clean. As far as I can tell, it looks essentially 100% original. Nothing really sticks out to me as being very obviously changed. There's a couple of things that do look like there has been some work done outside of this circuit board here, but everything looks very, very good. You've got kind of the classic, I think people call them blue turds, if I remember correctly, all of these caps here. I don't believe these are considered very, very high quality, but yeah, we will definitely check for leakage on those. We've got these white Mallory caps. Again, I don't know anything about those. This whole bias circuit is very different from what I'm used to looking at with the blackface era. It looks like it's got two different bias caps here, this kind of flying resistor. You got the bias pot, but it is laid out differently. Yeah, all in all, just very, very different. So fairly foreign to me. We're definitely going to have to look at the schematic and see if there's a layout and try and understand this. But visually, it looks very good. I also know that these red wires tend to go pink. I've seen that before. So, that just further shows just how clean and untouched this example is. So let's look over here at the 3-prong cable. You'll notice, hopefully you can see that. Let me do this. It's got what looks like your classic wire nuts here, joining wires. I'm not really sure what. So yeah, this is definitely a mess. Obviously not factory. So I don't know who did this, but the first complaint from the owner was that the original 3-prong was frayed, as you can see there. So yeah, that will absolutely be swapped. So that's the first thing on the list is a new 3-prong, no big deal. And yeah, everything else looks pretty good. But before we dig any deeper into this side and check every resistor and compare it to the schematic, we're going to go ahead and flip it over because I'm really curious about the doghouse. So let's go ahead and do that now. All right, so let's go ahead and remove the doghouse. Looking at the transformers, I guess we can do that real quick. Look at the codes. So this one is 606702. So I believe that means this is a 77. And then this one right next to it, the power transformer. Focus that. Is 606709. So I would also point to 77. And then the output transformer, which is just a beast, 606713. So these are all the original transformers and they date to 77 as far as I can tell. Go back over here to the doghouse. We'll go ahead and remove these screws. So let's see what we got. All right. Interesting. So as far as I can tell, so these two are definitely original. These are the Mallory caps, 70 microfarad, 350 volt. Those look original for sure. These are like a weird bronze color. Let's see if they have a brand on them. General Electric, interesting. GE. Alumalytic dry electrolytic capacitor. 020982. No idea how to date these. So these, I guess you can see the pencil marks too. the 3 plus symbols there. So these were left and these 3 were swapped for some reason. And these look very old. They're the same kind of cardboard wrapped capacitor, just like you see on these Mallorys, which kind of the same thing they had going all the way back to the Tweed era. So looking at that, I don't see visually. Yeah, I don't see any sign of bubbling on any of them, but obviously these caps are very old and it's just best practice to go ahead and swap those. So that will be also part of my recommendation, is swapping these caps. So these are both 70 microfarad, 350 volt, one going positive going that direction, one positive going this direction, with 2 resistors on the side. Let's see if I can see what color they are. Looks like red, red, yellow. So those would be 220 Ks. So actually this is exactly like the setup in the Pro Reverb I just worked on. So 2 220K resistors, 2 70 microfarad, 350 volt caps, and then these are all 20 microfarad. Looks like these are 550 volt. So yeah, so this actually looks identical more or less to the setup in the Pro Reverb, which is kind of interesting. We've got 2 resistors there. So let's see what we want to do next. While we're here, let's just go and check the value of these 2 resistors. I don't believe I'll be able to get measurements off of these 220Ks, so I'm not going to worry about that right now. But let's go ahead and grab the multimeter. Well, actually, let's first just confirm there's no voltage. I did already do this prior to filming, but I'll do it just for video because it's good practice to show people. So you can see there, no voltage. And standby switch is off right now. So great. Let's go ahead and check the value. And then I will grab my phone and pull up the schematic. Let's put that over here. So this resistor should be a 4.7K 1 watt, and it is a 5K, so that's fine. That's within tolerance. Jot this down on my here, so that's good. Now the one next to it should be the 1K 1 watt. And it's bang on. So those 2 are perfectly fine. These 2 20Ks, I'm not sure, but that's not a big deal. We can easily swap those once we swap these caps, assuming the owner is okay with that. So now let's do a visual inspection of everything up close. I'm going to grab the camera and hopefully give you guys a good view of everything so you can see what I see. All right, so here are the capacitors that were swapped. And then visually, let's look at the tube sockets. Let me zoom in a little bit. There we go. Those look fine. Oh, this one's loose. Okay, so we need to tighten that one. Tighten V2. Looks fine. Looks fine and tight. Got a little stamp here. Don't know what that says. Looks fine. Oh wow, look at this one. See if I can get a different angle here. This one has got a chunk out of it. Go even lower. Not sure how that happened. Something must have banged into it or something. So that's a bit of a bummer. So we will definitely need to swap this tube socket. Make a note of that. Here are the transformers. They all look good. Then the back of it, somebody put their name on it. Let's see what fuse it's got in it. It should be a 2 amp slow blow. I don't know if you can see that, but it is a 2 amp slow blow. So that's good. I will not try and put that back in one-handed. And then you got your courtesy outlet. Cool. So let's go ahead and flip it back over and look at the other side of the chassis. Okay, so we're on the other side now. Let's go ahead and look at it from left to right. We've got the bias circuit here. Looks like all original diodes. Yeah, everything looks original here. The original Mallory cap. There's that flying lead I talked about. Here's the unusual bias circuit I've never seen before. And then here is the questionable mess. But everything else looks good. Let's see if we can see the tube sockets there. So it looks like you got the original resistors on the tube sockets. Here's the phase inverter section of the circuit. Interesting to see that these are not gold band, because those are typically gold band resistors. Combing through everything. It all looks pretty good, actually. Nothing is really jumping out to me as not original. But you guys in the comments will probably be able to see something I am not in the moment. It's also hard to do with a camera in your hand. All right, let's go over here. Cool. So I guess I'm going to go ahead and put the camera off to the side so I can look a bit closer myself without it in my face. And yeah, I will pull you guys in if I spot anything. Otherwise, you'll probably just see a time lapse of me checking all the resistors next to the schematic. All right. Some interesting solder joints here. I don't know if you can see that. This wire right in the middle of your screen. There's actually like a hole in the solder joint there. But it looks factory. Obviously from this era, not known to be as high quality as the blackface era. Here's another where the bias cap is. You can see there's a hole in the eyelet with no solder. Not sure how that happens. So we got some solder joints to touch up for sure. Obviously, we're going to want to replace the bias cap, or caps, I guess, in this case. The diodes are probably fine. And yeah, we'll go ahead and check all the resistors now and see if there's anything that's way off. And then as far as these caps, I'm really not sure. I would assume it's a good practice to replace these Mallorys. As far as these blue turds, I'm really not sure. I know it's pretty common for people to swap these two right here because this is a pretty critical spot in the circuit. But yeah, I think we'll probably just check and see if they're leaking first and then make that call afterwards. So time to pull out the multimeter and check resistors. All right, so we're going to go ahead and start here with the bias circuit area. We can see it here in the schematic. So we've got all of those diodes I pointed out earlier, and then we've got a 1K resistor right here, which would be this one, if I understand this correctly. I am still learning how to read these schematics. Layouts are much easier for obvious reasons, but I could not find a layout for this amp. So we'll see what this reads. 1.2K. So we'll put that as, let's see here. So we'll put that as borderline. And then we've got that going into a diode, which is right here. And then we've got this. It looks like 3075, but I think it just kind of messed up on the drawing here. And it should be 8075 because I see it's 8075 on the cap there. And then we've got this resistor right here, which is then going over to this other 8075, which is right here. So we'll definitely want to be replacing this and this. Those bias caps, you're definitely going to want to make sure those are fresh. So this looks like it's supposed to be a, I want to say 3.3K. I'm still learning how to read the codes on the resistor. Some of them I know now and recognize, but others I don't. Yep, so that's supposed to be 3.3K and that's dead on, so that's totally fine. So that's good. So moving over here, these other resistors, looks like this, we've got a 15K. And a 100K here, so this looks like this should be the 100K. I'm not sure if we're going to be able to see this or not. This 100K right here, I believe, is this resistor. Let's check that real quick. And it is, so that one's totally fine. Let's check this one. Now this should be the 15K, I believe. Still climbing a little bit. All right, that looks like about 16K, so that's totally fine. And then it looks like that should be a 10K linear pot, which it is. So that's great. And it looks original, so that's not surprising. Perfect. So now let's go ahead and move on down the circuit here. We've got on the tube sockets, we've got the screen grid, and gosh, I always forget the name of these two resistors on each of the power tubes. Grid stoppers, I can't remember the name. I'm learning, guys. We're getting there. But we can go ahead and find those real quick in the schematic and note the voltages. So obviously these are always the 470, these 1 watts. So let's confirm that they measure correct. These are hard to measure with the little grabber hooks on the multimeter here. We'll just hold it in place. So this one's fine. Okay, both of those are fine. And then those are 1500s underneath. Perfect. And perfect. Beautiful. That's good. I know those can be a problem sometimes, but they do look good. They don't look burnt or anything, so. If it looks okay, my vote is to keep it. I know not everyone agrees with that, but that's all right. Man, I'm really curious about the mess under here, but we'll save that for later. And also there are these caps going from looks like pin 5 to pin 8. There are these 0.002, or I guess 2000 picofarad 1 kilovolt caps. I've never seen that before. That's not something you see on the blackface amps. And they both look okay. But yeah, I've never seen that before. So I think those will be fine though. So let's go ahead and shift the amp down and continue checking out the circuit. So this is where I get really confused on the schematic versus a layout, trying to kind of trace. This is actually going to be good for me to be able to get better at this. So we're going to have to kind of take a little bit of time and trace out where everything goes, so we understand, you know, like for example, I know this is the phase inverter kind of section. You can see the wires going to the tube here, which is the phase inverter in this amp. What is that, V4, which would be a 12 AT7, which would be right here. So I know this is the general vicinity I should be looking at. And then I can obviously read these caps here. This is a 0.047 and 600 volt. There's one right there and one right there. Then we've got 100K 5%er. That's that resistor right there. It is a silver band, which is interesting. Doesn't look like the solder joints were messed with. So, but a 5%er should be a gold band. So that is interesting. See what this measures. 108. So that is out of tolerance. That's not a 5%. That's obviously 8%. So we will recommend changing that. And then looking around here on the schematic, we've got two 47Ks. I don't know if these are 47K. That value I'm not too familiar with as far as color code is concerned. They are, so that's 48, and those 47Ks do not say they need to be 5%ers, so that's fine, and that measures great. They both measure great. Perfect. So let's go and mark those as good. We've got our other 0.047, 600 volt here. This little guy, I can't really read. It looks like it's a 0.1. Let's see if we can find that on the schematic. 0.1, 200 volt. So there that is on the schematic. Can you guys see that? Yeah, you can. So connected to that, we've got one side going to ground, and there should be a 22K, and two 330Ks, a 470 ohm, all kind of together in this vicinity. So let's see what we're looking at. 22K, I believe, will be this one right here. I believe red is 22. Yep, that's totally fine. And then next to that will be two 330Ks, which would be these orange. I know orange equals 33. So you guys, I'm slowly picking it up here. So that's 312. So that's fine. $313, that's fine. And then this says 470. This does not look like a 470 ohm resistor. Looks like a 1 meg or something. Okay. Wow, it's 470. The color is like, almost looks like blue, brown. That's weird. So this is reading 690. So I'm going to put a question mark on that one. The actual resistor looks like, I gotta look it up. Maybe I'm, well, no, because these are 470 right here, and these are yellow, purple, brown, and that's not yellow, purple, brown. So I think it is a, yeah, I'm not sure. I'll need to look up what that color code is, but I think that's the wrong resistor. That just happens to be a similar value. I could be completely wrong, but this is what you get, guys. You get me doing this in real time, and we're just kind of doing it. It is what it is. What else do we got here? We've got a 047. I can't, whoops. We got a 047 600 volt. This is a 0.01. So where is this in the circuit? So this right here, 47K and 100 picofarad, that's this right here, I believe. 47K, let's confirm what that measures. Dead on. Just make sure that's right. My hand was a little bit in the way. Yep, 47K. And then we got the 0.1 right here. Now let's go ahead and slide everything down a little bit. Where's the 100? Okay, here's the 100K 1 watt. Right there. And there's the other one. So here's the 200K 1 watts. So let's check those. $86K. It's a bit low. I'm not really sure, I guess, how to tell which one is which. Because they're both going to the same preamp tube, V3. So on the schematic, how to tell, I guess this one's got a couple caps piggybacking off of it. Not necessarily seeing where that is. Okay, I see now. So this has got a 407. Well, that's another 100 ohm or 100K. So that's not there. So there should be a 100K next to another 100K. See that? So I don't know if you guys can even see this. So this right here, this 100K, it's got a cap across it that I can barely read. Looks like 500 picofarad or something. I can't really read it. And then it's got this resistor right here, which appears to be 100K. Brown, black, yellow is 100K. So there should be a connection somewhere between 100K 1 watt and 100K normal half watt. So that's where I'm trying to find right now. So I see 1500 and 25, which I believe is this one. So we can check that real quick. Oh wow, it's hidden. Okay, there's two, it looks like. Is that right? Two 1500s. So on both tubes. Yeah. So you can see there's 1500, and it looks like it was scratched out, but it should be a 25, another 1500, 25. I believe that's right here. No? Well, there's 1500s right here and 225. So that's wrong, possibly. All right, this is where I'm going to take a little bit of trial and error. You guys are getting to watch me literally try and figure this out for the first time. So we've got the 100K and 100K. Both of them, the problem I guess I'm having right now is how to determine which one is which in the schematics. We've got one here and one here. So this is connected to pin 6 of the 7025 for V3. Okay, pin 6 is this one. Okay, there we go. So that's a good way to do it. So pin 6 is right here. So this 100K right here. And you guys probably want to be able to see this. This is what I'm looking at. 100K, 1 watt, connected to pin 6 is this one. And that measures 86. That's, 14% off or so. I'm going to say that should be replaced. And then the other 100K is here, and that's also off of pin 6. That's off of pin 6 for, that's going to be this one right here. Okay. We're getting confused here, folks. So this 100K is right here, if I understand correctly. Which I think I'm figuring it out. So this 100K, 1 watt, right here is off of pin 6 for the other 7025, because it's going to the same pin right here. And that measures 83, so that's also low. So, I mean, maybe not critical. I'm not really sure exactly off of pin 6. I don't know enough yet to be able to say offhand if that's critical. It needs to be closer, but it's out of tolerance, so it's just worth noting. And then here's the other one off of pin 6. Oh gosh, there's more. There's more 100K 1 watts. There's 2 more here. So this one's a mystery. I don't know where that is. This one goes to pin 6 on this one, so we can check that real quick so we have it up. Wow, so they all read a bit low. So I'm going to say those are not like crazy out, but possibly worth changing. So we got to figure what this is. So let's see if we can find any other 100K 1 watts in the circuit. So here's another one. 100K 1 watt with a 500 picofarad. There we go. Okay. With the 500 picofarad strapped across it. So that's that one right there. And I think it's this one. So that's connected to pin 1. Yes. Okay, perfect. So it's pin 1, 100K 1 watt. I would think it would be for this tube though. 6, 8. I feel like I'm missing something. So see how this 7025, it's not opened up like these, like they're using this tube. It looks like, again, I'm not familiar with this circuit, but it looks like this V3, if I understand correctly, they're not using the full 12x7, the 7025 tube. Whereas these, see how it's kind of split into halves, and they've got all this stuff going on. It looks like they're using less of this tube right here, which is a bit confusing to me. So I'm not seeing where I'm still a little confused on this right here, because it looks like the lead of it is going here to V3, and I don't see anything off of pin 1 on the schematic here. I see pin 6, pin 8, pin 7. And then the other two, so the 2 power tubes. You can see here's the phase inverter split. All right, I'm not sure yet. We're going to circle back to that. Let's find this 220K and this 1500. So off of pin 8 for V3, we should have the 1500 and a 2525. So pin 8? It's this one. So pin 8 is right here, and then off of that should be a 25, which there is, and a 1500. So that's right there. Sometimes these are really hard to get a good connection. So that's perfect. Beautiful. And then we got off of pin 7 a 220K. If I can get this back out. So off of pin, where am I at? So off of pin 7, that's going over to a pot. Gosh, I am really confused now. Pin 7, there should be a 220K. But pin 7 is going to the volume pot of the second channel. Maybe this schematic is wrong. Or there's like different base 50 schematics. That could be a thing because, I mean, unless I'm misunderstanding this, you guys can tell me or I'll find out by the time this goes live. Pin 7. So there's 9 pins here. So 9, 8, 7. 7 has just got this shielded wire and that's going there. Whereas it says pin 7 should have a 220K to ground. That's nowhere to be found and it should be a 0.01 as well. Now off of pin 6, there should be another 220K. I don't see that anywhere. So I feel pretty sure now that this is this schematic is for a different, I guess, version of the base 50. Unless I could be missing something. I really could be, but maybe. So this shows a 27K 1 watt and a 16 volt 450K. The only way, so you would have a 16 volt 450, or sorry, 16 microfarad 450 volt, excuse me. The only way you would have a 16 volt 450 microfarad cap would be in the doghouse. You wouldn't have that out here. It'd be huge. And we looked at the doghouse and it had these caps. It had a 320 microfarad 525s, just like you see here. And then it had 270 microfarad 350 volts, which you see here. And that's it. So this is a schematic for a different amp, is what I'm learning. Because this right here, this 16 450 and a 27K 1 watt, that would all be in the doghouse where we were in the other side. So now I've got to go ahead and do some research and figure out what's going on. TBD, if I upload this video now and wait for you guys to point me in the right direction, because I'm really not sure how to look that up, or you guys will, this will cut and you'll see me with a new schematic figuring this out. So either way, thanks for watching. Stick around or wait for the next episode. See ya.